Okay, so now this thing's moving and there's an accelerator here. Okay, just don't question the existence of these things. Let's assume that there is an accelerator that can exert a forward force of that much for 2.1 newtons. What speed are we going at the top? So at the top, we'll be moving, right? At the top, notice that we've got potential energy. You always have potential energy at the top, right? And then we're also moving, okay? Now there's no mention of a force that slows us down, so I think that guy doesn't exist, okay? At the bottom, we are moving. We don't have any potential because we're at the bottom, okay? Um, but there is a force that speeds us up, right? So remember, this right side one is a force that slows you, and the left side one is one that speeds you up, okay? The reason that we don't have a slows you force is that this is an accelerator. It's one that's going to go on this side, okay? So when we write this out, it'll look like this: 48 times 2.10. That's our force times distance, right? It's moving, so we've got 1/2 15 times 7.1 squared. And then at the top of the hill, we've got potential energy, right? So it's 15 times 9.8 times the height is 2.15. And then it's moving at some speed. So 1/2 15 times v squared, right? So the v is what we don't know. We know everything but that v. So I'm going to do this entire left side. So 48 times 2.1. Then plus 0.5 times 15 times 7.1 squared. This whole left side is 478.875. Let's figure out this term too. So 15 times 9.8 times 2.15. That's our 316.05. And then plus 1/2 15. Sometimes the math, is the hardest thing, right? Okay, so then I'm going to go this minus this guy. So 478 minus 316. And I get 162.825. And that's 1/2 15v squared. All right, so I'm going to take this guy, multiply by 2, divide by 15. And that's v squared. So 21.71 is v squared. And then I'm going to square root this, both sides. So second square root, second answer. And I get 4.659. V is meters per second. Ta-da.